Okay, hello there. I am Matthew Pashkowski, and this is my recording for CS5335 Homework 3, Mission to the Moon. We're starting with the rocket. This is the Kerbal 1C, which is something I've made modifications on from the Kerbal 1. I needed to add more solid fuel and added a complete new liquid engine phase with a few tanks. So now if I go to the launch platform, we'll wait for Kerbal to load up. Then we open the terminal, edit the program, copy in our program, save the program, run the program. So the rocket is going to go up. This is roughly the same launch code that I submitted with my homework 1. So what's going to happen is the rocket is going to burn straight up until it is out of solid fuel. Then once the solid fuel is used up, it will start to turn proportional to 1 minus the apoapsis height divided by the target apoapsis height. This rocket, not the most well-designed rocket. It is currently very much flexing and flopping around, but I thought it would be able to get this job done. So now that the solid fuel has been used up, we are continuing to use that bottom liquid fuel. As you can see, the apoapsis is still pretty far away from our target of 75,000, so we're still going fairly straight up, though it is definitely going with some horizontal movement. Okay, we just staged off of the bottom liquid fuel, and now we have the liquid fuel engine that I added to the Kerbal 1. This is the same engine as the bottom liquid fuel engine, because I realized that I needed to continue using a higher thrust output engine. Okay, now that the apoapsis has hit target height, we are going to start aiming down, and now we are going to zoom out to the so that way we can see the moon orbit, because that's what's important at this point. We just staged, so we're on the final liquid. The rocket is still propelling itself basically horizontally to try to gain a circular orbit. So here we go. You can see some of my test Kerbal 1s from homework 2, because this was done on the same sandbox career mode file. Okay, we are almost at the point where we're actually going to start orbiting Kerbin. It's almost circular. Okay, so from here on out, what it is trying to do now is increase its apoapsis until it is in line with the moon. I have been having some issues. I tried doing just 180, and obviously because the moon moves over the course of the rocket getting there, that wasn't successful. But trying to increase that angle more led to stupid, ugly numbers where it immediately fired into this stage despite having a wait command. But now the apoapsis has reached the orbit of the moon, so we are going to wait and we're going to speed this up. As you can see, it does one loop and misses the moon, then it's going to come back, just barely missed the moon that second time. It's going to go for a third pass, fourth pass. This is going to be a lot of pass. Okay. So, yep, as you can see, we got signs that not this one, but the next pass, it's going to run into the moon. And so now we are in the moon's sphere of influence. We're getting affected by its gravity. So we are coming down here. Time to apoapsis infinity. So now what it is waiting for is to be 10,000 above the altitude, at which point it's going to try to use the remnants of its liquid fuel straight up and hope that it survives. I was not able to build a rocket that actually contained landing legs. I don't understand how to use those. And the one time I tried putting some on, it ruined the aerodynamics of this rocket so much that I wasn't even able to achieve an orbit around Kerbin. Okay, so now we are coming in. Still going to be a little bit, but we're going to switch to the rocket view. What's going to happen is once it reaches that 10,000, it's going to flip, point straight up, and then fire down. So that's what it's trying to do. And I was not able to successfully land. This has been my submission for homework 3, CS5335, Matthew Pashkowski.